Okay. For this last type of problem, um, you're going to do a linear regression. Let's see what this question is. Here's an international corporation and their estimates of sales in the coming year based on how many weeks or which week they're selling stuff. So looks like their sales are going down week by week. Use a linear regression to model the data. This might be a straight line down. Look at how the sales, they just get worse and worse. From week one was just pretty good. By week 8 is like half of that amount. Week 11, okay. So they want you to use a linear regression to model the data. That means see if there's a line that fits these XY points pretty well. Round your coefficients to decimal. So you've done this before. The last thing, the new thing though, they say, use a residual plot to determine if your model is a good fit. I'll explain that in a minute. So let's copy these values for the calculator and let's open that statistics calculator. Okay. So let's paste those values in and we're going to go to the calc menu and they want us to try to model a line that goes through those data points. Now, this is the new thing that you're going to do, residual plot. I'll explain that in a sec, but this time you want to show it. Okay, so calculate. Alrighty. Okay, what is this? First of all, you know you have to go back. We'll come back to this. You need that A and the B to calculate your equation. So let's go back and do that first. The model is y equals, and what do they want? They wanted thousands of dollars. No, 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 no. You round your coefficients to 3 decimal places. Okay, I need my slope to have 3 decimal places, negative 376.454. But guess what? Decimal place number 4, this is a 5, so that's going to trip this up to a 5. X plus 4951090, whoops, 4951.090, and then the 4th decimal point is a 9, so I'm going to make this into a 1. Okay, so far so good. Now, the model, I got some choices. Is a good fit or is not a good fit? Well, let's go back to this residual plot. Here's what is happening, okay? What this is showing is how far each of the data points is from the line that we just made the equation for. Now, the line, it's not, this is not the line, okay? The line, as the weeks go by, sales is going down. It's terrible what's happening to this company. As the weeks go by, sales are going down. So that's the actual line. And then the sales figures are like the data, right? Like this week it was pretty bad. That week is getting worse. But it's not like sitting on a perfect line. What this shows is how far each of these points is from that line. How far is that from the line? How far is this one from our line? How far is that one from our line? Whether it's above or below. And here's the thing. If it's random, it's a pretty good fit. If it's random, it's a pretty good fit. If it is not random, and you'll see an example of this, maybe next time, here's our line. But guess what? The data, kind of like this. Wouldn't it be better to not have a linear model, but a quadratic model? Wouldn't it be? So if the residual plot follows a certain kind of pattern where it's small, then large and small, or if it follows a pattern, it's not a good fit. But when it's random, that's a good fit because it just happens to be randomly above or below, and there's no pattern that it wants to be. It just kind of like follows that line, but goes up and down. It's above or below it in a random way. So when you look at that residual plot and you notice that it is random, you're going to say, hey, no, the line did a good job because it does not show a clear pattern. Okay, so let's look at so this is what all these sales figures by week are, these yellow dots. The line that we got the slope and intercept for is like that. And sometimes it's above, sometimes it's below. And that was our residual plot to show whether it's below or above. But if it's as long as it's random, it's pretty good. But you may get a problem like this. And it's very hard to tell by looking at the data, you know, about the residuals. But the data below, same thing. Here's a company. Here's their sales. Use a linear. They want a linear regression. So go ahead and do that just like you did before. Round your coefficients 3 decimal places just like before, but use the residual plot to see if your model is a good fit. So when you go into the calculator and you hit show residual plot, and this is our last problem, but this time what you're going to see, and I'm going to skip to the solution, is your residual plot is going to look like this. And what this is telling you is that, you know what? Your line is not terrible in getting close to these dots, but you were better off using some other model. Probably, maybe it's a quadratic, maybe it's exponential, but because this fits a pattern of like being off by a certain logical amount, it's a pattern. This model is not a good fit because the residual plot shows a clear pattern. So you shouldn't have used linear. But they tell you to use linear, so you should use linear. The other, as far as I can tell, the other choices, these are just there to confuse you. So don't worry about these. Look for whether it's a clear pattern or not a clear pattern, and that'll tell you whether your linear plot is a good fit or not a good fit.